There's a couple of them like this actually that I don't know what's going on. 300 gram block on a 58 centimeter long string swings in a circle on a horizontal frictionless table at 90 rotations per minute.
So we're looking down, this is like a top view of this.
Okay.
What's the mass of it?
300 grams.
And the 58 centimeters.
Mm-hmm.
It's just going in a circle here.
90 RPMs.
So that would be omega.
Yeah.
So if this block goes around the circle one time, or 90 times every minute, how far is it if it goes around the circle just once? Like what's the distance it traveled?
If it just 90 per minute.
So don't worry about this for right now. How far does this go around in just one revolution? What's the distance it travels? Yeah, so it'd be 2 pi times the radius, right?
Yeah.
It's 58. Let's change that to 0.58 meters.
5, 8. Okay, so 3.64.
Okay. So how far does this go in 1 minute? It's going at 90 revolutions per minute.
Okay.
So this is how far it goes in 1 revolution.
I'm stumped, I don't know.
So it'll go, this is 1 revolution,
Mm-hmm.
and then you're doing 90 of those every minute,
Okay,
times 90.
okay.
And then you want to find it per second, right? So there's 60 seconds in every minute. So wait, per second, sorry. That's how far it'll go in 1 minute, so then you divide by 60 to get seconds.
Okay, so 2 pi times 0.58 times 90 divided by 60. 5.47.
Okay. Now, that's kind of the intuitive way to do it, is saying, well, every revolution is 1 times the circumference. And then you're doing 90 of those every minute, and then you divide by 90. The other thing you can do is take omega equals 90 revs per minute. And then you take that and you say, well, there's 2 pi radians in every revolution. Those cancel. And you say there's 1 minute every 60 seconds. And those cancel. Then you end up with 90 times 2 pi over 60 radians per second. That's your new omega.
Okay.
In order to get your velocity, velocity equals omega times r, as long as omega is in radians per second.
Okay.
So then you can say velocity is equal to 90 times 2 pi all over 60 times 0.58 meters. And that'll be in meters per second, right? And this is the same exact thing as that.
Yeah.
So that's your velocity is 5.47 meters per second.
Okay. So that's what I put for speed, it's the velocity.
Yeah.
4, okay, and then what is the tension in the string?
Okay. So tension would be this force right here, right?
Mm-hmm.
So what's the free body diagram for that block look like? We'll ignore the forces going this way. So like we're looking down, so gravity would be pointing into the table,
Mhm.
and the normal force would be pointing out. We'll ignore those ones.
And they just cancel out.
Yeah.
So, you got your tension force pulling towards the radius.
Yep.
And then do you factor in centripetal force?
So centrifugal and centripetal forces, they're kind of like imaginary forces. So the reason that you feel, so when you go around a corner, what we talk about like a centrifugal force, the force that pushes you to the outside of the car. What's actually happening is that the friction between the tires on the car is pushing the car in, and so your body is just running into the side of the car as it tries to turn.
Okay.
So your body's trying to go straight and the car is turning.
Mhm.
So that's an imaginary force. This is actually the only force acting on it.
Oh, okay.
And
So it's
then,
just-
so you'd sum your forces in the R direction. So this is R, this would be T, this is the R direction for your coordinate system.
Okay.
So you have just T, and that equals mass times acceleration. What kind of acceleration points towards the center of the circle?
I don't know.
So you have tangential acceleration, then you have the centripetal acceleration, which points straight towards the center.
Okay.
So since this is moving in a circle, it has some centripetal acceleration, right?
Mhm.
Do you remember what the centripetal acceleration equation is?
I don't. I have it written down somewhere.
It's v squared over r, right? Yeah.
Okay.
V squared over r. So T is going to be equal to the mass times v squared all over the radius.
Okay.
And you want to use kilograms and meters. So T will be equal to 0.300 kilograms times 5.47 meters per second all over, that's squared, 0.58 meters.
5.47 squared
Yep.
divided by 5.8. Okay, 15.48.
And then you got 0.3 times all that? Okay,
Yeah.
so tension is 15.48 newtons.
Yep.
Okay.
Wow, that's complicated.
So with circular motion, anytime you're doing forces and something's moving in a circle, you'll have centripetal acceleration,
Okay.
which is going to be dependent on the speed.
Alrighty.
So,
So let's see here. Oh, I got these ones. Let's see. There was another one. It was a little different. This was spinning on a. Let's see. A conical pendulum.
okay.
Couldn't figure this one out either. Conical pendulum is formed by attaching a 0.7 kilogram ball to a 1 meter long string and then allowing the mass to move in a horizontal circle radius 10 centimeters. And it's asking for the tension of the string and the ball's angular velocity.
So it kind of goes in a cone,
Mm-hmm.
and this is 10 centimeters,
Yep.
0.7 kilograms.
Yeah,
That's the mass, and then this is 1 meter.
Mm-hmm.
Right?
Yeah.
It says they're allowed to move a horizontal circle. Okay. So, if you were to draw a free body diagram of this weight, what would the forces be on it?
Let's see, gravity.
Okay. So that'll be 0.7 times 9.8.